So my topic is on review in detail anesthesia machine, standard of monitoring, vaporizer, breathing circuit, scavenger. So as we know, the anesthesia machine is a gas delivery system that has 4 components: supply, delivery, supply, processing, delivery, and disposal of the gas and the volatile anesthetics that's given to the patient, and you dispose of carbon dioxide and the exhaust volatile anesthetics. So the main 3 system that we have is the high pressure system, you have the intermediate pressure system, and your low pressure system. The high pressure system consists of your cylinder pressure, which is your backup cylinders. Forgive me for my bad drawings, but it's your nitrous, your air, and your O2 tank in the back of the anesthesia machine that is in your high pressure system, your hanger yoke, and all the connections. The pipeline is your main source of gas for your nitrous, air, and your oxygen. All of this will have a filter, check valve, a pressure gauge, and a pressure regulator. So each one will have filter, check valve, pressure gauge, pressure regulator. Even in the pipeline, you have a filter, check valve, pressure gauge, and your pressure regulator. This is your first pressure regulator. The tank pressure, as we know, a full tank will be very high. So the nitrous is 745 psi, and that contains 1590 liters of liquid nitrous gas. It's converted, the pressure regulator will decrease it to 45 psi. The pipeline that comes from the hospital hose has the safety mechanism, which is the diameter index safety system. The tank has the pin index safety system, filter, check valve, pressure gauge, and your pressure regulator. This is reduced to about 50 to 55 psi, all of them, 50 to 55 psi. And preferentially the anesthesia machine will take the gas from the pipeline instead of the tank because of the higher pressure. The nitrous also has a fail-safe valve, which is connected to your oxygen pressure sensor. So when your oxygen pressure drops below 21 psi, your pressure alarm will go off, so you have an audible alarm that will go off, and this will activate the fail-safe valve, which will automatically shut off your nitrous gas in order to prevent any hypoxic mixture to the patient. Some machines also have it for air, some don't. So the modern ones, the air may not have the fail-safe system. The fail-safe system is not for the oxygen, it's only for the other gases connected to your machine. I want to also mention the intermediate system also has your oxygen flush valve, which is connected directly to your pipeline. This is 35 to 75 liters per minute of oxygen flow, 100% of oxygen, and it's at about 50 psi pressure. So high pressure, high flow, and when you're using the flush valve, just be cognizant that you're giving, you can cause barotrauma, you can dilute your anesthetic gases, and cause patient awareness. All this is now connected to your, you have your flow control valve. Flow control valve is also in your intermediate system. Flow control valve is connected to your flow meter. Flow meter has these glass, it's a calibrated device that will has the throat rotometer or your ball that will tell you how much flow of nitrous, air, or oxygen you're providing. The nitrous and oxygen is interlinked by the link 25, and it prevents any hypoxic mixture by the provider. So if you reduce your oxygen flow to, let's say, less than 25%, it will automatically reduce your nitrous if you're also giving nitrous at the same time. So its proportion is 3:1, so nitrous and oxygen is at the ratio of 3:1. It's called the nitrous oxygen proportioning safety system. So that's another safety system that the anesthesia machine has. Now, your flow meter, the oxygen is set at your right-hand side so as to give maximum oxygen to the patient and not on the left-hand side. But I think it's only in the US that they have that. Some other countries don't have that. This is connected to your vaporizer. So your vaporizer dial is your agent-specific temperature compensated. So you have your liquid vaporizer here, and as Andrew mentioned, the vapor pressure of each, like sevoflurane or desflurane, whatever you're using, the vapors are on top, and you have these wicks on the side, which is saturated with these vapors, and your gas is going to flow and pick up the vapors and come out of whatever percent you have dialed. And some of the gas will bypass that and go. So it's called the variable bypass system that vaporizes, that is used. It picks up the gas. Now you're ready to give it to your patient, and it goes through your common gas outlet, which also has a check valve. Common gas outlet is now connected to your circle system, which is your breathing system. So why is it called a circle system? Because all your gas is moving in a circular fashion, and you are titrating the gas and the vaporizer. So you can use a semi-closed or a closed circuit system. You connect this to your inspiratory limb. So you have your inspiratory valve that gets connected to your O2 sensor. So your O2 sensor is the most important indicator that will tell you your oxygen concentration. And it is the best indicator to tell you if you're giving a hypoxic mixture to your patient. This goes to your Y connector, and that has also your gas sampling sensor. And this goes to your lungs, to your patient. Your expiratory limb is connected to your spirometer that tells you all your volumes, tidal volume, minute ventilation volume. It's connected to your airway pressure sensor. This goes to your expiratory limb. You have your expiratory valve connected to your bag and vent selector, and that's connected to your APL valve. So your bag and vent selector, if you have the patient spontaneously breathing, you want your APL open and not closed. And if you're selecting the vent mode, it's connected to the vent. That's your ascending bellows, ascending meaning when you're expiring, the bellows is going to ascend. The APL is connected to your reservoir bag, and the vent also has a ventilator spill valve. So the APL and your ventilator spill valve is connected to your scavenger system, which has this reservoir bag as well. And your scavenger system is connected to the hose, the purple hose that you see connected to the disc, to the wall, and the hospital will take care of the disposal of the anesthetic gas that we have given. A word on the, I forgot to mention one more thing, sorry. Here, the inspiratory limb and your expiratory limb is connected to your CO2 absorber, and as we know, we use the soda lime or the AMSOP. So your carbon dioxide that's exhaled for your patient this has like 10 to 20% of water that gives carbonic acid, and your carbonic acid will be neutralized by your soda lime, which is either sodium hydroxide or calcium hydroxide, and will have a neutralization reaction. You get Na2CO3, which is sodium bicarb, plus water, plus heat. So if you have a dry CO2 absorber, you have to be careful because you're gonna have carbon monoxide in if you're using desflurane, and CO can give compound A formation with dry, desiccant, and low flow system. So,